Good afternoon, everyone. We are now doing Rsk4805, which is market risk. And my name is Renos Musha. And if you want to contact me via email, that's my email address. And if you contact me via phone calls or via WhatsApp, that's my WhatsApp number as well. So I'm going to be taking you through Rsk4805, where I'm going to be assisting you going through the study units with assignments as well as revision, which is everything that you need between now until you write your exams during the Jan-Feb period next year. So what we do is that every session that we have, it's also recorded, which means that in case you missed a class or there's something that you want to go through that you missed during the class as well, and you want to review it as well, you are able to go through, review it, because once you're registered with us, you are able to create a user account, and on our website, you will be able to access the soft copies of the textbook, as well as the videos going through the material as well. So my advice would be, today we're going to go straight into looking at topic 1, and in topic 1, we're going to be looking at chapter 1 of the textbook. So please make sure that you go through the video that I've sent you the link via WhatsApp, where there's a YouTube video. And on that YouTube video, it gives you an overview of the module. And also it gives you orientation, where we tell you exactly what to expect during the year, how to access the material on our website, and also how to access the videos on our website as well. That video basically demonstrates all those things as well. So I would recommend that you go to that particular video, because it's very, very important, because it gives you a guideline of exactly what you should expect when you go through the curriculum until you write your exam next year. So when I look at your assignments, I see that your assignments due date is starting in May. So what I'll do is that after this week's class, when we meet for the next class as well, I'll also tell you exactly when we're going to be having a class where we are going to be going through the assignments as well. So please take note of that. So in the next class, during the course of the week, I'll make an announcement on exactly what approach you're going to be using when it comes to the assignments as well, because most likely some of the assignments will do them in class, and some of the assignments are going to be doing them in an additional schedule that we're going to be making as well, so that we maximize the hours that we have already scheduled so far. So if you don't have the link to the timetable as well, please remind me, because on our website, we already have the timetable, which shows you when we're going to be having the classes between now until the end of October, because that's when we should be done with the study units, which is the learning units as well. Then we'll post another timetable again, end of September, sometime in November, which is going to be the revision timetable, which is going to be for the period of November, December, January, until you write your exams in February as well. We'll post another timetable so that you know exactly when we're going to be meeting for revision as well. When you go through revision, we review the questions from the current assignments, and we review the past question papers as well, so that we're able to create the question papers and create the memos for those past question papers as well. So far, our database up to 2023 for the new curriculum is up to date. So as soon as the exams are going to be written for the May-June period, that's when we're going to be updating our exam memos as well, so that you're able to use them during revision. Is there any questions? Before we start on with study unit 1? So please note that we are a private tutorial service provider, which is independent of UNISA. And what we do is that we assist students with everything that they need between now until they write their exams with UNISA as well. So anything that you need in between, we're able to assist you, which means that we assist you to go through the study units. We also give you guidelines on exactly how to approach the assignments, and also we assist you with revision as well. Now, looking at the learning units that we're going to be doing, you will see that for Rsk4805, we have 9 learning units. So for Rsk4805, we have 9 learning units. And please take note that anything that was covered before 2020 is no longer relevant, because before 2020, your curriculum was based on derivatives. So there was a textbook with 9 chapters, which introduced you to derivatives, and then also looked at application of derivatives as well. Now, in the new curriculum or the new textbook, it's a totally different textbook. So please note that when it comes to revision material, even if you get other material from somewhere else as well, the only past exam papers that are relevant is 2021 going onwards. Anything before 2021 is not relevant. The only past assignments that are relevant is 2020 going onwards. Anything before 2020 is not relevant. So please take that into account so that you avoid. I remember the students who were joining us for revision during last year, they were bringing in questions which are not necessarily relevant for us for the new curriculum as well. So please make sure that you take that into account. So you'll see that for your curriculum, there are going to be 9 learning units. So there are going to be 9 learning units. And in those 9 learning units, there are going to be different chapters which are covered under each learning unit as well. So when you look at learning unit 1, they ask us to look at chapter 1 of the textbook. And remember, this is all coming from topic 1. So topic 1, you find that there's going to be learning unit 1 to 3. So for learning unit 1, we look at chapter 1 of the textbook. Then when you look at learning unit 2, so moving on to learning unit 2, you see that learning unit 2 covers chapters 2 to 4 of the textbook. So learning unit 2 covers chapters 2 to 4 of the textbook. So please bear that in mind as you go through. So I would always strongly recommend that when you are covering the material in the textbook, always refer to your study guide, because the study guide basically tells you exactly what, for the next learning unit, which chapters are relevant. And you'll see that even in some chapters as well, there are certain sections that the lecturer says leave out and certain sections that you're obviously expected to do. So please make sure that you go through and understand what is being stated in the study guide before you attempt each learning unit as well. Then moving on to learning unit 3, you see that for learning unit 3, we are expected to cover chapters 15, 16, and 18 of the textbook. So you need to look at chapters 15, 16, and 18 of the textbook. And these are the 3 learning units that makes up what? Topic 1. Now moving on to topic 2, you see that topic 2, they ask us to look at learning unit 4 to 6. And for learning unit 4, you are going to be expected to look at chapter 5 of the textbook. So for learning unit 4, you need to look at chapter 5 of the textbook. Then learning unit 5, you look at chapters 8 and 9 of the textbook. So there's no sequence. The sequence of the study guide is not the same as the sequence of the textbook. So please make sure that you take note of that as well. Then when you move on to learning unit 6, you see that learning unit 6 covers chapter 10 and 11 of the textbook. So learning unit 6 covers chapters 10 and 11 of the textbook. Then from there, we look at topic 3, and topic 3 looks at chapters 12 to 14 of the textbook. So it covers chapters 12 to 14 of the textbook, which means in this case, learning unit 7, you need to look at chapters 12, 13, and 14 of the textbook. Then learning unit 8, for learning unit 8, it's still topic 3, where you're looking at chapters 7 and 22 of the textbook. So for learning unit 8, you need to look at chapter 7 and chapter 22 of the textbook. Then moving on to the last topic, and the last topic looks at learning unit 9. And learning unit 9 looks at mistakes to avoid, which is covered in chapter 29 of the prescribed book. Usually, we don't take long to cover learning unit 9. In less than an hour, we would have covered learning unit 9 as well. So these are the different learning units that you need to make sure that you cover based on the different chapters that are going to be covered in the textbook as well. Please note that the soft copy of the textbook is available, so you are able to access the soft copy of the textbook as well. And if you check the link of the video that I shared as well, it also shows you exactly how do you access the soft copy of the textbook, how do you access revision material, and also how do you access the videos going through the curriculum, and how do you access the videos going through the revision as well. So all that is covered in the video that covers orientation and overview of the curriculum. So please make sure that you go through that particular YouTube link that I sent you. If you don't have it, please let me know, because you need to go through that so that when you now start attempting the different learning units, you know exactly what to get and where to get it as well. So are there any questions before we start with learning unit 1? Any questions? Now, remember we said for learning unit 1, we need to look at chapter 1 of the textbook. So for learning unit 1, we need to look at chapter 1 of the textbook. And in chapter 1 of the textbook basically gives us an introduction to market risk. And here they say, the chief risk officer, I always read the highlighted sections. So the chief risk officer as chief risk officer, it is your job to consider how the new venture fits into the company's portfolio. So what is the correlation of the performance of the new venture with the rest of the company's business? When the rest of the business is experiencing difficulties, will the new venture also provide poor returns, or will it have the effect of dampening the upwards and downwards of the rest of the business? Companies must take risk if they are to survive and prosper. So the risk management function's primary responsibility is to understand the portfolio of risks that the company is currently taking and risk it plans to take in the future. So it must decide whether the risks are acceptable, or if they are not acceptable, what action should be taken as well. So that's basically the risk management function of the organization. So which means the reason why companies operate is mainly because they need to compensate the investor for taking that extra risk. That's why you see that any formulas which look at estimation of what the required rate of return should be for a particular company, they always are going to be based on accounting for a risk premium. So in order for us to estimate how the company is going to be able to perform, we can look at table 1.1, which shows us the 1-year return from investing 100,000 in a stock. So we're looking at investing 100,000 in a stock, and now we're finding out exactly, so how much would be the return that we're expecting to generate if we invest 100,000 in the stock? So they tell us that there is a 5% probability, so 0.05, if you multiply that by 100, and to make it a percentage, it means there's a 5% probability that this stock is going to give us 50% return. There's a 25% probability that this stock is going to give us a return of 30%. There's a 40% probability that this stock is going to give us a return of 20%. There's a 25% probability that this stock is going to give us a negative return of 10%. And then there's a 5% probability that this stock is going to give us a negative return of 30%. So based on these projections, now we need to find out exactly, so what is the relationship between the expected return that we're going to be looking at as well as estimate exactly, so what, for this return that we're expecting, how much is going to be our risk exposure? Because for every return that you pursue, there's always going to be risk that you're going to be exposed to as well. So when you look at risk versus return for investors, they say As all fund managers know, there's a trade-off between risk and return when money is invested. The greater the risk taken, the higher the return that can be realized. So the trade-off is actually between risk and expected return, not between risk and actual return. So the term expected return sometimes causes confusion. In everyday language, an outcome that is expected is considered highly likely to occur. However, statisticians define the expected value of a variable as its average or mean value. So expected return is therefore a weighted average of the possible returns, where the weight applied to a particular return equals the probability that the return occurring. So the possible returns and their probabilities can either be estimated from historical data or assessed subjectively. That's why you see that when you look at the relationship between return and the possible returns as well, we're looking at their probabilities and the possible returns. And please take note, probabilities of returns, they always add up to 100 if you put them as percentages. If you put them as decimals, if you add these numbers, they should add up to 1. If these probabilities are not adding up to 1, it means that something is missing or there's something wrong with the allocated probabilities. So based on these possible returns and their probabilities, we can be able to determine the expected return for a single investment. Remember, in this case, when you look at this particular investment, we are told that this stock, we're investing 100,000 in this stock, and these are the possible returns that we're expecting to generate from this particular stock as well. So which means we're now looking at measuring the risk and return of a single asset. There are formulas that you need to make sure that you bear in mind. And these are the two formulas. So which means in this case, for a single asset, the expected return of the asset is given as the sum of the returns of the individual assets multiplied by the weight of probability of return. So for a single asset, the expected return of that particular asset is given as the sum of the possible returns multiplied by the probability of earning those returns. And that's how you are able to determine the expected return of a single asset. So if you're asked to determine the expected return of a single asset, that's the formula that you should use. Next, remember we said we're now looking at the linkages between risk and return. Now, when you're determining the risk of a single asset, the first step that you need to do is to determine the variance of that asset. And for a single asset, the variance of that asset is given as the return minus the expected return squared multiplied by the probability. Now, this expected return is basically this R with the bar on top. So this R with the bar on top. So the expected return can also be given as the R with the bar on top. So this is the expected return. So whatever amount you determine as the expected return, that's what you're going to be using now to determine what? The variance. So the variance can be calculated using that information, using this particular formula. Then from the variance, we can now be able to determine the standard deviation. And the standard deviation is given as theta squared. So this is the sign for the standard deviation, and this is also this is the sign for the standard deviation, and this is the sign for the variance. So this with on its own, that's the standard deviation, and this sign with the 2 on top, that's basically represents what? The variance. So your standard deviation is simply the square root of the value that you got as the variance. And this is how you're able to determine standard deviation. Are there any questions so far when it comes to measurement of return and risk of a single asset? Any questions? Please note, the expected return or the expected value, sometimes they also represent it as mu. So sometimes the other notation that they can also use there is to say the expected return can also be written as mu. So which means where you're saying R out the bar on top, sometimes you can also represent it as what? As mu. So if you see the notation mu, or you see the value, the bar on top there, it's basically the same thing. It's representing expected return. So from the given information, we now need to be able to determine the expected return, from there, the variance, and then from there, the standard deviation. So what do we see? Remember now, this single asset, which is the stock that we're investing in, they give us these probabilities, and then they also give us these possible returns as well. So now we need to find out exactly, so how do we determine the expected return of this stock? And how do we determine the risk of this stock by determining what? The standard deviation as well. So from the given information, it would mean the expected return would be given as, for the first scenario, your possible return as a decimal is, remember the possible return is 50%, as a decimal is 0.5, multiplied by the probability of that return is 0.05. So you always put probabilities as decimals. So you always put probabilities as decimals. The returns, you also have to put them as what? As decimals. The sum of means you are summing up for every different scenario that you are having there. You need to sum them up together. By summing up means you're saying plus. You go on to the next scenario. The return is 30%, which is 0.3. The probability of that return is 25%, which is 0.25. Plus, because you're summing up, go on to the next scenario. Your return is 10%, which is 0.1. The probability of that return is 40%, which is 0.4. Plus, because you're summing up the different scenario. The next scenario, your return is minus 10%, which is minus 0.1. And the probability of that is 25%, which is 0.25. Plus, because you're summing up. Next scenario, your return is minus 30%, which is minus 0.3. And your probability is 5%, which is 0.05. So given this information, how much would we get as the expected return of this single asset, which is a stock? How much would you get as the expected return? So if you do the calculations there, how much would you get as your expected return? How much do you guys? How much do you get as the expected return? So for the first scenario, or the first bracket, you must be able to get a figure of 0.025. For the second bracket, you must be able to get a figure of 0.075. For the third bracket, you must be able to get a figure of 0.04. The next bracket, you must be able to get minus 0.025. And the last bracket, you must be able to get a figure of minus 0.015. So if you do the addition and subtraction there, you must be able to get a figure of 0.1. But remember, your expected return is the percentage, which means you need to multiply that by 100 to make it a percentage, which means your expected return in this case is equal to 10%. Are we on the same page? Any questions? Anyone lost? Now we need to calculate the variance. Now we need to calculate the variance. Now remember we said for every observed return, you need to subtract the expected return in brackets. You put it to the power of 2, and for that scenario, you need to multiply that by the probability of the return. And remember we said the expected return in this case is 10%, and as a decimal is 0.1, which means for the first scenario, in brackets, your observed return was 50%, is 0.5. Your expected return is 10%, is 0.1, squared multiplied by the probability of earning that return, which we said is 0.05. Plus, because remember, you are doing it for all these different scenarios. For the next scenario, your observed return is 0.3 minus 0.1 squared multiplied by the probability of 0.25 plus. For the next scenario, your observed return is 0.1 minus 0.1 squared multiplied by the probability of 0.4 plus. For the next scenario, your observed return is minus 0.1 minus your observed expected return of 0.1 squared multiplied by the probability of 0.25 plus. For the next scenario, your observed return is minus 0.3 minus the expected return of 0.1 squared multiplied by the probability of 0.05, sorry, 0.05. So given this information, we can now be able to determine the variance, because we use the variance to determine the standard deviation. So given this information, how much would you get as your variance? How much would you get as your observed variance? So how much would you get as the variance?
I'm getting 0.036.
Yes, that's correct. Because for the first one, you must be able to get a figure of 0.008 for the first. Then the second one, you must be able to get a figure of 0.01. The next one is 0. And the next one is 0.01. And then the last one would be 0.08. So these are the values that you're supposed to be getting on the calculation that you're doing between these plus signs as well. Which means if you add them up together, you must be able to get a figure of 0.036. Now, to determine the standard deviation, we are simply going to say the standard deviation is the square root of 0.036 because that's the variance. So how much would you get as the standard deviation? How much do you get as the standard deviation? To 4 decimal places, you must be able to get a figure of 0.1897.
1897.
Yes. Then if you multiply this by 100 to make it a percentage, you will see that your standard deviation is going to be 18.97%. So this is how we determine the standard deviation of a single asset. Are we on the same page? Any questions? Anyone lost?
Hi, sir.
So, Mhm.
On my side, I don't hear anything. Remember, let's talk about myself. Really, when it comes to calculation, it's very huge problem on my side. So when you go step by step, just show us which one are you taking when you calculate, and then also that what do you call it? The R1, the expected one. If you write R, just write it in full weight so that we know which risk is that and the return one. Because when it's two of them, then I'm getting confused. Thank
Remember,
you.
your R is basically your observed return, and your R with a bar on top, which is also your mu, which is also your your E with a in R within bracket. And this represents your expected return. So whenever you see the R of the bar on top, or you see a mu, it's basically expected return, which can be written as this, and this represents your expected return. So that's what basically this represents. And PR basically is short for probability of the returns, of earning those returns as well. Are we on the same page? And remember, we said this sign, basically, if it's got a 2 on top, it means it's your variance. And if it's just this sign on its own, it basically represents what? Your standard deviation. Please note as well, what I'm suspecting might be another question would be, remember we said this is to the power of 2. Remember we said this is to the power of 2, right? On your calculator, it means you're going to open brackets. You type in, for example, 0.5 minus 0.1, you close brackets. Now you want it to the power, put it to the power of 2, right? There are two ways that you can do on your calculator. Whenever you want to put something to the power of, you need to press the button with the Y and an X on top. The moment you press this button with the Y and an X on top, it basically means that you're saying, whatever I've entered before, I want to put it to the power of something. So what is this value of X? Then you now put 2. And then when you say equals to, then it means you have now solved for this part of the calculation. So if you're not sure about your calculations or you're not proficient with calculations, rather separate these. That's why we are putting a plus sign on every set of calculation or every scenario. So please take note, when you want to put something to the power of on your calculator, you look for this function with Y with an X on top of it. This is how you're indicating that you're putting whatever you've written before to the power of 2. Are we on the same page? Any questions? When you are looking for the square root, you only, on your calculator, you only look for use the square root with this. You don't use the square root with a star sign or whatever sign that is there. You don't use this particular square root sign. So this square root sign, you don't use it because it's not for you. It's not relevant for your curriculum for now. It talks about something else. So whenever you want to put something to look for the square root of something, look for that square root sign, which doesn't have anything decorated on it, just the square root sign on it. That's how you look for the square root of a particular value. Then when you press that button, then you say 0.036 equals to, you get your answer. Then you need to multiply that by 100 to make it a decimal. So to make it a percentage, sorry, because your answer, your calculation is decimal, so your answer you're getting is also in decimal as well. Is there any way you need me to clarify? Any questions? Anyone lost? So when you do this particular calculation, whenever you're given a long calculation like this one, always make sure that you rather separate this, do this calculation separately, and then do this calculation separately, do this calculation separately, do this calculation separately, do this calculation separately. You get your answer like what I've done here. You indicate that for my first calculation, this is my answer. For my second calculation, this is my answer. Third, fourth, and fifth calculation. Then you add them up together. It makes your life easier. And remember, in the exam, your lecturer wants to see your working. So you are able to get more marks. Like, for example, maybe you are sitting in the exam with a 49%, and the lecturer is just trying to push you to a 50% mark as well. If you show as much of your working as possible, the lecturer can now be able to be generous enough to push you to get a 50%. So because of this, they always encourage you to show as much of your working in the exam as much as possible. Are there any questions? Any questions? Anyone lost? Now, when we do calculations for Rsk4805, please take note. In your textbook, for demonstrative purposes, you see that sometimes they round off your answer to 4 decimal places, sometimes to 5 decimal places, sometimes to 8 decimal places as well. Now, what you need to bear in mind is that when we go through the answers in the textbook, we do it according to the textbook. but prepare yourself for how they also expect you to round off your answers in between calculations in the exam as well. So if you look at a typical exam paper, let's look at the May-June 2023 paper. If you look at the May-June 2023 paper, you see that these are the instructions that they typically give you. Remember, they give you this information about the examiner app and open book examination, answer all the questions as well. And then they say, pay special attention to the structuring and numbering of your answers. Number the questions is the same as the exam paper. Then of importance, they say, round all calculations to 4 decimal places with final answer to 2 decimal places unless otherwise stated. This statement is very, very important. So this statement is very, very important because you need to, in the exam, they will tell you exactly how, unless they tell you something else. When you do your in-between calculations, like getting the answer here, getting the answer there, getting the answer there, and there as well, they say round off your calculations to 4 decimal places. Then when you now arrive at your final answer, like what we've done here, when you now arrive at your final answer for the standard deviation, that's when you round it off to what? To 2 decimal places. So please take note of the special instructions that they give you for typical questions like this one in the exam. Are we on the same page? As you can see, you will see that some questions in the exam, they will indicate how many decimal places you should round off your answers to. Just trying to look for an example of a question where the in-between calculations, they'll tell you exactly how many decimal places you should round them off to. Yeah, you see, for question 3.1.3 in the exam, remember they say your in-between calculations, round them off to 4 decimal places, isn't it? Now here they say round calculations to 8 decimal places. So which means instead of rounding off your in-between calculations there to 4 decimal places, here they are specifically asking you to round it off to 8 decimal places. But under normal circumstances, your final answer, you can leave it in what? In 2 decimal places. So please note that in the exam, they will tell you how many decimal places you should round off your answers to. So in the exam, they will tell you how many decimal places you should round off your answers to. If it's not stated, you use the information in the front page where they say round off your in-between calculations to 4 decimal places, and then your final answer 2 decimal places. Our final answer for expected return, we round it off to 2 decimal places. And even if you round it off here, there was no need for us to round off because it's already 10.00 is just the same as 10. That's why we didn't round it off. But here, for standard deviation, we rounded off our answer to 2 decimal places, which is 18.97. But now in between calculations, we rounded them off to 4 decimal places. So in the textbook, there is no real consistency. Sometimes they change, but note that in the exam, you need to round off your calculations into 4 decimal places and your answers in 5 to 2 decimal places. Then unless otherwise stated, where for a specific question, they will tell you how many decimal places to round off to.
Sorry, Mush. Hello? Hey, can you make another example of what you're saying? I'm just lost a bit in terms of if they say 8 decimal places, so can you make an example of that?
Remember the calculation that we did here. Remember they say round off your answers to 4 decimal places, isn't it? And then your in-between calculations to 8 decimal places. You see that here, when we calculate the variance, we round it off to 4 decimal places, isn't it?
Okay.
So where you round off your answers to 8 decimal places is where you're going to say, now, if you're looking for the square root of, what's the square root, sorry? If you're going to be looking for the square root of 0.18, 97. You see that the square root of that would be equal to the square root of 0.1897. The square root of 0.036. 0.036. Okay, what do we have here? The square root of 0.036. How do we make it decimal? Is it decimal? Yep. You see that if you round it off to 8 decimal places here, the answer here, you would be getting give me a second.
Okay.
You'll be getting a figure of 0.18973666368. So you'll be getting this figure, right? So that's when you're rounding it off to what? To 8 decimal places. Are we on the same page?
Can you
Are we
refresh me
together
again?
now?
Sorry. When you say,
Sorry?
okay, which one are you using? The square root of 0.189.
No, the
Hello?
square root of 0.036. 0.036. The square root of 0.036.
Okay. How did you go to this, get this
Which calculator are you using?
0.189?
Which calculator are you using?
I'm not using the right calculator here. It's fine.
Which one are you using?
No, I don't have a calculator with me yet.
Are you using the phone?
Sorry? Yes,
Are
I'm
you
using the
using the
phone.
phone? Huh?
Yes.
You on the phone you have the square root sign.
Okay, yes, let me just open a second.
So we're looking for the square root of 0.036.
Okay, here it is. Okay. Okay. The
Are
square
you
root
getting the
of
longer?
so I'm okay, I'm on now. So we have to put the square root first, then 0.036
Equals to.
okay, then it gives me 0.06. I don't know if I put it right.
Clear your memory first, then you say square root sign 0.036.
Square root sign 0.0036.
Not 0. Only 10. Remember the
sorry.
0.036.
So sorry, it's me, I was wrong. Okay. It gives me okay. Many digits anyway. It's 0.18973 Okay, I see. I can see now.
So which means if you put it in 8 decimal places, this is the value that you get.
Okay.
But remember, in the exam, they say round off your in-between calculations to 4 decimal places. So this value, if this value to 4 decimal places, you're going to look for the 5th value, isn't it? This 5th value is less than 5. So you're going to be taking only these values. You're not going to be adding 1 to that last value, isn't it? So which means to 4 decimal places, your answer is going to be 0.1897 to 4 decimal places.
Oh, okay. No, I get it. Thank you. I get it now.
Any other questions? Anyone lost? Please note, this method of arriving at the variance and arriving at the standard deviation, this is the method that I'm assuming that you should be familiar with, because this is the most common method of arriving at the variance and the standard deviation for those who have studied financial management or investment management or any other modules at undergrad. The most common method is this method as well. There is another method that they also demonstrate in the textbook. I'm just showing you, but don't worry about it. So in the textbook, you will see that when it comes to the demonstration of risk, so you see that when it comes to the quantifying of risk, they use a different formula for arriving at the standard deviation. So they use this particular formula. Take note of it, but don't worry about it. Remember, there's a lot of concepts or new concepts that are going to be teaching you for market risk. So what I'm avoiding is teaching you new things. If there is a way that you are already familiar with of how to get to point B, rather I show you the method that you're familiar with than teaching you a new method as well, because there's quite a lot of information you need to grasp. So there is another method of quantifying standard deviation as showing in the textbook, but don't worry about this method. Rather use this method to determine the variance that I'm sure that I'm assuming that you should be familiar with this formula for calculating the variance if you've studied financial management or investment or any finance module as well, and then standard deviation using this. Because if you check in your textbook, you will see that when it comes to the standard deviation there as well, you will see that your standard deviation is you're going to be arriving at standard deviation using this particular method as well. So you basically get to the same answer. Are we on the same page? Any questions? Anyone lost? Now, remember we said when it comes to the risk-return relationship, you can be asked to find the return of a single asset, which is the expected return. You can also be asked to find the risk of a single asset, which is the standard deviation is shown by this formula as well, right? Now, your investment is not only expected to be made up of one asset. Your investment can also be made up of what? 2 or more assets as well. So when you have 2 or more assets, it basically means that you have a portfolio of investments. Now we need to find out exactly, so how do you ascertain the return or the expected return of a portfolio of investments? And how do you ascertain the risk, which is the standard deviation of a portfolio of investments as well? So on section 1.1.2, they talk to us about those weights. I'm going to discuss these weights. Then they give us that particular portfolio formula for determining the expected return of the portfolio. I'm going to discuss this. I'll also demonstrate this. Then they also give us another formula for determining the standard deviation of a portfolio, and I'll also discuss this as well. So these are the two formulas that I'm going to be discussing when it comes to determining the expected return and also the standard deviation of a portfolio. Remember now, the difference between what we're doing now here compared to what we've done previously is that in the previous calculation that we did, we were assessing the expected return and the standard deviation of a single asset. Now, when you have two or more assets, you now have a what? A portfolio. Now, if you have a portfolio, how do you determine the expected return and the standard deviation of that particular portfolio as well? So that's the next thing that we need to do. Now, we are analyzing a portfolio of two assets. So I'm looking at analyzing a portfolio of two assets. Now they're saying, if you have a portfolio of two assets, how do you ascertain the expected return, and how do you ascertain the associated what standard deviation of that particular portfolio as well? So the expected return of a portfolio, so the expected return of a portfolio is given as the expected return of asset A multiplied by the weight of asset A plus the expected return of asset B multiplied by the weight of asset B. So which means in this case, so the sign at the bottom there is indicating which portfolio, which assets are you dealing with, and the P is basically indicating that it's a portfolio. Are we on the same page? Next, we also need to look at the standard deviation of the portfolio. Now, for the standard deviation of the portfolio, the standard deviation of the portfolio is given as the let me just indicate the variance first to avoid confusion. Okay. The variance of the portfolio is given as the standard deviation of asset A squared multiplied by the weight of asset A squared. Remember, squared means to the power of 2. Plus, for portfolio B, the standard deviation of portfolio B multiplied by the weight of portfolio B. Plus 2 multiplied by the weight of portfolio A multiplied by the weight of portfolio B multiplied by the correlation coefficient of portfolio A and B, of asset A and B, multiplied by the standard deviation of asset A multiplied by the standard deviation of asset B. So this is how we determine the variance of portfolio. So this is basically the variance. So this represents the variance of the portfolio. So from there, the standard deviation of the portfolio is given as the square root of the variance. And this is how we determine the standard deviation of one. Any questions? Anyone lost? So they give us an example. So please note. Remember we said this expected return. So this expected return can also be written as R with the bar on top, or can also be written as mu. So if you see the R with the bar on top, or you see the notation mu, you should know they're talking about one and the same thing. So from here, if we check on the example that they give us in the textbook, they say, suppose that mu1 is the 10% per annum. Remember, mu1 is your expected return of asset 1, which is asset A, right? So we can put it as asset A, or we can put it as asset 1 as well. And it's 10%. So to avoid confusion, where I was saying A or B, I was trying to avoid confusion, but let's rather use the notation that they have in the textbook so that everything, no one gets lost. They can clearly see the notations there, but it's basically one and the same thing. Because we can say asset 1 or 2, or you can say asset X and Y, or you can say asset what? M and N, whatever notation that you use there, it still gives you the same thing. So here we have asset 1, weight of asset 1, we have asset 2, and the weight of asset 2 as well. And the same applies here for the variance. Standard deviation of asset 1 squared times the weight of asset 1 squared. Standard deviation of asset 2 squared times the weight of asset 2 squared. Weight of asset 1 times the weight of asset 2. The correlation of asset 1 and 2. Standard deviation of asset 1 and standard deviation of asset 2. So if you say C, A, and B, or asset 1 and 2, or asset X and Y, you should know it's just a notation that they're using there to show that there are two different assets there. Are we on the same page? So going back to the question, they say, suppose mu1 is equal to 10% per annum. So which means, suppose the expected return of asset 1 is 10% per annum, and the standard deviation of asset 1 is 16% per annum, while mu of asset 2, which is the expected return of asset 2, is 15% per annum, and the standard deviation of asset 2 is 24% per annum. Then they also say, suppose you also that the coefficient of correlation, which is written by this particular formula. So this sign basically means coefficient of correlation between the returns is 0.2, or if you put it as a percentage, is 20%. Table 1.2 shows the expected return of the portfolio and the standard deviation of the portfolio for the number of different values of weights of asset 1 and 2 that you're going to be able to get. So if you check on table 1.2, they are basically telling us that if you use a weighting of 0% to asset 1 and 100% to asset 2, this is how much the expected return you should arrive at, and this is how much the standard deviation should arrive at. If you use a weighting of 20% to asset 1 and 80%, remember, take note that just like probabilities, weights always add up to 1 or 100% as well. If you put them as decimals, the weight, they should add up to 1. So that's why you see that 0 plus 1 is equals to 1. 0.2 plus 0.8 is equals to 1. The weight of 0.4 for asset 1 and weight of 0.6 for asset 2 still adds up to 1. So given this, they are telling us that if you do the calculation, this is how much you should get as the expected return of the portfolio, and this is how much you should get as the standard deviation of the portfolio. So from table 1.2, which weightings or which possible combination of weightings do you want us to use there? Which possible combination of weightings do you want us to use to arrive at the expected return and also to arrive at the standard deviation of the portfolio? Which combination? You can choose any. You want the first combination, the second one, the third one, the fourth one, the fifth one, the sixth one? Which combination would you prefer then?
Can we use the third combination?
The third combination would be this one, right?
Yes.
All right. So the third combination is that we should give a weighting of 0.4 to asset 1 and a weighting of 0.6 to asset 2. So if we do the calculation, we should get an expected return of the portfolio being 13%. And if we do the calculation, we should get a standard deviation of the portfolio being 16.89 as well, right? So remember, the information, apart from the weightings there, the information is already given to us on the question, isn't it? So we know asset 1 has an expected return of 10%. Asset 2 has an expected return of 15%. Asset 1 has a weighting of 40%, which is 0.4, and asset 2 has a weighting of 0.6, which is 60%. So given this information, we should be able to determine the expected return of the portfolio, isn't it? Well, from the information there, it would mean, we would say, for the expected return of the portfolio, the return of asset 1, we told that it's 10%, right? So as the decimal is 0.1. Multiplied by, I prefer to put it in brackets so that I know that I'm solving this separately and then I solve this separately. So to show that, to make my life easier, I prefer to put it in brackets. Multiplied by the weight of asset 1. Remember we said asset 1 will give you the weighting of 0.4 plus The expected return of asset 2, we were told on the question that the expected return of asset 2 is 15%, which is 0.15, and the weighting of asset 2 is 0.6. So given this information, how much would we get as the expected return of the portfolio? If you do the calculation, how much do you get as the expected return of the portfolio?
So it will be 0.04 plus 0.09.
Yes. So it will be 0.04 plus 0.09. And how much do you get as the expected return?
0.13.
So 0.13. And to multiply that by 100, it gives you an
13%.
expected return of 13. Remember, we are just skipping this because 13.00 is the same as simply what? 18, because the zeros there are just placeholders. Any questions? Anyone lost? All right. Can we take a 10 minutes break? Can we take a 10 minutes break? It's 13 minutes now, 3:27. All right, can you take a few minutes break until 3:40? Can you take a few minutes break until 3:40? And then at 3:40, we look at calculating the variance of the portfolio. Then we look at the standard deviation of the portfolio as well. So during the meantime, please review what we've done. When we resume, if there's any questions on what we've done previously, I'll address them before we move on. So can you take a few minutes break until 3:40? Are there any questions on what we have covered so far? Any questions? Any questions on what we've covered so far? So we can now move on to calculation of the variance for a portfolio. So we can now move on to the calculation of variance for a portfolio. Now remember they say the variance of a portfolio is given as the standard deviation to the power of 2 of asset 1 multiplied by the weight to the power of 2 of asset 1 plus the standard deviation squared of asset 2 multiplied by the weight of asset 2 squared plus 2 multiplied by the weight of asset 1 multiplied by the weight of asset 2 multiplied by the correlation coefficient of asset 1 and 2 multiplied by the standard deviation of asset 1 multiplied by the standard deviation of asset 2. So this is how you determine the variance of a two-asset portfolio. Now, looking at the variance for a two-asset portfolio, please take note. Please take note. The correlation coefficient of asset 1 and 2 multiplied by the standard deviation of asset 1 multiplied by the standard deviation of asset 2. This represents the covariance of asset 1 and 2. So you need to check on your question, what are they giving you? Are they giving you the covariance of asset 1 and 2, which means this part is already done? Or are they give you the correlation coefficient? If they give you the correlation coefficient, it means you need to multiply that by standard deviation of asset 1 and standard deviation of asset 2. But if they give you the covariance of asset 1 and 2, it means this part of the calculation, they've done it for you already, because we are saying the covariance of asset 1 and 2 is given as the correlation coefficient of asset 1 and 2 multiplied by the standard deviation of asset 1 multiplied by the standard deviation of asset 2. So you need to check on your question, what are you given? Are we on the same page? Any questions? Anyone lost? So from the given information on the question, remember on the question, before we took a break, on the question, they had given us the standard deviation of asset 1, which is 16%. They had given us the standard deviation of asset 2, which is 24%. They had given us the correlation coefficient of asset 1 and 2, which was given as 0.2 as a decimal, which is 20%. So with that information, remember we also said in our analysis, we are dealing with a calculation where we are allocating a weight of 40% to asset 1 and a weight of 60% to asset 2. So based on this information, we can now calculate the standard deviation of the portfolio. So based on this information, we should be able to determine the standard deviation of the portfolio. So for the standard deviation of the portfolio, it would mean first we need to determine the variance. So for the variance of the portfolio, it's going to be equal to, remember they say for asset 1, the standard deviation was given as 16%. So 16% as a decimal would be 0.16 to the power of 2 multiplied by the weight of asset 1. We said we're allocating 40%. So it's going to be 0.4 to the power of 2. Close brackets. Remember I said, to make your life easier, rather separate these calculations with what? With brackets, isn't it? So for the second bracket, the standard deviation of asset 2 was given to us as 24%. So it's 0.24 to the power of 2 multiplied by the weight of asset 2, which is 60%. So it's 0.6 to the power of 2 plus. Remember we said to make our lives easier, separate this with the bracket, separate this with the bracket, and separate that with the bracket. Then from there, we're going to say 2 multiplied by the weight of asset 1, which is 0.4, the weight of asset 2, which is 0.6, The correlation coefficient, so we are given the correlation coefficient, so we have to write all these values as well. And remember, they say the correlation coefficient is 20%, which is 0.2. So it's 0.2 multiplied by the standard deviation of acid 1, which is given as 0.16, multiplied by the standard deviation of acid 2, which is equal to 0.24. So given this information, can you calculate the variance of acid 1 and 2? Any questions before we do the calculations? Any questions? Any questions? Anyone lost? Are there any questions? Is anyone lost? So can you do the calculation for the variance of this portfolio? How much would you get as the variance? how much would you get as the variance?
For the first one, I'm getting 4.096 times 10 to the power negative 3. I don't know if that's correct. But
You're
if
getting a figure of what? 4?
if I 4.0096 multiplied by 10 to the power negative 3. Yeah.
What this means
I do it.
is that you need to move. What this means is that you need to move. If it's 10 to the power of minus 3, or I think it's Casio, right? On your Casio
Yes, it
calculator.
is. It is. Yeah.
What it means is that you need to move 3 decimal places from the current decimal place. If you're going to put it.
Okay.
So you need to move 3 decimal places to the left, basically.
Yeah.
If it's minus 3, means you need to move 3 decimal places to the left. So you are going to move 1 decimal place, 2 decimal place, 3 decimal places. So you're moving 1, 2, 3. So your comma is going to start here.
Okay.
So your ultimate value becomes 0.004096.
Okay.
Yeah. So with the Casio calculator, that's if you're not having the option to put it in decimals, that's basically how you put it in decimals like that.
All right.
All right. Any other questions? So you find that if you do the calculation, can you please do the calculation? Please do the calculation. Let's see how much you get.
So that would be 0.004096 plus 0.02736 plus 0.0036, which would end up as 0.25. 0.025. And then percentage, it would be 2.5%.
So here you get 0.00425.
Yes, 40 0 again. Yes, 96. The one on top, yeah.
4096. 4096 like this.
Yes.
And the second one?
0.020 736.
736.
Yes.
And the last part?
0 0
0.00
3686.
686.
Yes.
Like this.
Yeah.
Now,
Yes.
if you add them up together, how much do you get?
0.025.
Put it into 4 decimal places at least, or 5, whatever. Just try to, because remember for demonstrative purposes, I think I'll just take into account as many decimal places as possible for demonstrative purposes. 0.02076, 0.3686. So you should be able to get a figure of 0.028512. Are you getting this amount?
Yes, I am. Yeah.
Right. So
Yeah.
any questions before we move on to the standard deviation? Is there any question? Anyone lost? So for the standard deviation, it's going to be the square root of your variance, which we're getting as 0.028512. So given this information, how much do you get as your standard deviation?
Uh, 0.168854.
168854.
Yes.
If you round it off to, if you choose to round it off to 6 decimal places, it will be 55, right?
Okay.
If you choose to round it off to 6 decimal places, it will be 55. Then if you multiply that by 100 to make it a percentage to 2 decimal places, how much do you get as your standard deviation?
16.89.
So your standard deviation would be 16.89%. Are we on the same page? Any questions? Anyone lost? So these are the values that we were expected to get. If you look at the calculation expected for weights, if we allocate a weighting of 40% to asset A, asset 1, and 60% to asset 2, your expected return that we got is 13%, and the standard deviation would be 16.89. So do you see that our rounding off is not uniform? But in the exam, the reason why I'm keeping it ununiform is because I'm trying to get answers close to the answers in the textbook as much as possible so that you can follow. But please note that in the exam, under normal circumstances, you round off your in-between calculations. These calculations in between here, you round them off to 4 decimal places, but then the final answer rounded off to 2 decimal places. The reason why I'm keeping it like this is mainly because I'm trying to give you and demonstrate an answer that is closest to the answer in the textbook. Because if I had rounded off my answers to 4 decimal places here, we would have gotten 16.88, not 16.89. If we round off to, if we rounded off our in-between calculations to what? To 4 decimal places, we were going to get 16.88. And still, it's acceptable as well. So please note, the reason why the lecturer emphasizes on people showing as much of their working as possible is mainly because they can be able to follow and see where you got from. And then they can be, if they are generous enough, they can give you hard marks as well. So going into the exam, try as much as possible to show as much of your working as well. Because the more working you show, the more you are able to accumulate those marks as well, because the lecturers will be able to follow where you got right and where you got it wrong. Then they can be, if they're in a good mood, they can be generous enough to give you, if it's supposed to be giving a mark, maybe they can give you half a mark for a particular part of the calculation. Are we on the same page? Any questions? Anyone lost? So, looking at this, they are saying, remember, this is one scenario that we chose to calculate, isn't it? There are other scenarios that you can also choose to calculate, where if you choose to invest 0% in asset 1 and 100% in asset 2, they are saying your expected return of the portfolio will be 15% and your standard deviation will be 24%. If you choose to invest 20% in asset 1 and 80% in asset 2, the expected return of the portfolio will be 14%, and the standard deviation of that portfolio will be 20.09%. Then if you choose to invest 60% in asset 1 and 40% in asset 2, your expected return of the portfolio will be 12%, and the standard deviation of the portfolio will be 14.87. And if you choose to invest 80% in asset 1 and 20% in asset 2, the standard deviation, the expected return of the portfolio will be 11%, and the standard deviation of that portfolio would be 14.54%. Then if you choose to invest 100% in asset 1 and 0 in asset 2, the expected return of the portfolio will be 20%, and the standard deviation of the portfolio would be 16%. Are we on the same page so far? So are you starting to see that there is some sort of relationship between risk and return? I'm basically saying, if you take this much risk, this is the expected return that you're expecting to get. Are we on the same page so far? So based on that information, I'm just making my screen smaller so that you can see what I'm trying to demonstrate. So based on that information, they are now showing us to say, if you plot this information on the graph, this is the graph that you're going to end up getting, where you are plotting the expected return against the corresponding standard deviation. Like, for example, we are saying, which one is which here? For example, if you plot this information on the graph, information, orientation. Okay. The lines. How do I do this with the line here? They just changed the settings on trying to look for, yeah, straight line. Okay. Now, how do I know which color to use? You want a straight line for which color? Right. Okay. So if you look at the information that they are plotting here, remember we said for an expected return of 10%. Just give me a second. Yeah, we're saying for an expected return of 10%, we are saying that the corresponding standard deviation is going to be somewhere here. Remember, this is based on the information that they gave us previously, where we are saying that when you're earning an expected return of 10%, your standard deviation of the portfolio is 16%, right? So which means if you go back to this, we're basically saying for an expected return of 10%, the corresponding standard deviation is 16%, like that. Do you see that they are now plotting this information on a graph? Are we on the same page? And where we have the lowest standard deviation, this is the standard deviation of 14.54. And an expected return of 11%. So if you check here, they're basically saying we're also saying for a standard deviation of 14.54, so for a standard deviation of 14.54, so for a standard deviation of 14.54, which is somewhere close to here, the corresponding expected return, they say it's 11%, which is somewhere halfway. It's not that my graphs are not that accurate, but it's somewhere there. So do you see now they are plotting these expected returns against the corresponding standard deviation, and then this is how they're coming up with the graph, which is like something like this. So do you see where this particular graph is coming from? Any questions there? So for this standard deviation, the expected return is 10%. For this standard deviation, the expected return is 11% roughly. So do you see how they are plotting this information here? Are we on the same page? Now, from the given information, they go on further. So they are now plotting this graph against the expected returns. So on the next section, we now look at the efficient frontier. So we now look at the efficient frontier. So which means with the efficient frontier, remember we said that there's a relationship between risk and return. And with every investor, they want to make sure that they're able to maximize a return for a given level of risk. And at the same time, they want to be able to minimize the risk for a given level of return, isn't it? So that's basically what every investor is trying to do. They want to maximize a return for a given level of risk, and they want to minimize the risk for a given level of return. So to do that, when it comes to the issue of the efficient frontier, now we need to find out exactly, so how does an investor end up coming up with an efficient frontier? If you go to the graph that we have here, there's a problem that we're already seeing on our particular graph. If we check on this particular graph, we will see that, remember we said, for example, this particular return, for this risk that one is taking, we're expecting this, that the expected return is going to be this. But what else do we see on our information there? Do you see that for the same risk, you are also able to earn a higher expected return? So for the same amount of risk here, there's a part of the graph where you are able to have a higher return. So remember we said for every investor, their goal is to maximize the return for a given level of risk. So which means for this given level of standard deviation, which is a risk measure here, we are better off investing at this point and getting this return than investing at this point and getting this return. Because remember, there is no point to take the same amount of risk but getting lower returns, isn't it? Because remember, for every investor, they want to be able to maximize the return for a given level of risk. So now, given this information, this is how the investor is now going to end up coming up with what? An efficient frontier. Because with the efficient frontier, this is what will enable you, this is the point on this graph that will enable you to maximize the return for a given level of risk. So which means, it basically means that the efficient frontier basically does away with certain combination of weights and then gives you that combination of weights which allows you to maximize a return for a given level of risk. So in summary, the efficient frontier is what we're going to be seeing now when we look at figure 1.3. Generally, figure 1.3 is basically saying that when you look at the efficient frontier, you're trying to maximize a return for a given level of risk. Are we on the same page? So the easiest way to explain the efficient frontier So when you look at the efficient frontier, in simple terms, we're basically saying, if you are given a set of investments, remember we said the efficient frontier is something like this. So when you look at the efficient frontier, we're basically saying our aim is to invest in these investments that are found along the efficient frontier. So our aim is to invest in these investments which are found along the efficient frontier, because these are the ones that allow us to maximize return for a given level of risk, and they also allows us, the efficient frontier, the investment along the efficient frontier allows us to minimize risk for a given level of return. So that's what the efficient frontier enables us to do. So to understand the efficient frontier, let's say, for example, you have these investments. So let's say, for example, you have these investments. If you have investments A and investment B, which of these two investments would you choose to invest in? If you're given investment A and you're also given investment B, which of these two investments would you choose to invest in?
I think the one on top, is it A or B? The one on top.
Yes, because for the same risk level, B gives you a higher return. If you put it in numbers to understand, let's say if your standard, if your risk level, let's say for example, it's your standard deviation. If your risk level is going to be, if your standard deviation is, let's say, 15%, we're basically saying that A gives you a return of 10% and B gives you a return of 12%, which means for a risk, for the same risk exposure, you are better off investing in B than what? In A, isn't it? The same question would also arise if you're asked to compare investments Let's say, for example, you're asked to compare investment C and investment A. If you're asked to compare investment C and investment A, investment C is plotted here. Which of the two investments would you choose to invest in between investment C and investment A?
Investment A.
Investment A, because for the same return,
Under any.
Is it
for the
not?
same return, yes, for the same return, investment C is giving you, for the same return, investment C is exposing you to less risk, isn't it? Please take note of that. So if I asked to choose between investment C and investment A, because they're earning the same return, for the same return, you would choose to invest in investment C. Why? Because for the same return, you have a lower risk exposure of 10% compared to 15%. Are we on the same page?
Mm.
Are we together then? What if you're asked to choose between investment C and B? What would you choose? If you're asked to choose between investment C and B, which one would you choose? Your choice of investment C and B depends. Choice between C and B depends on risk appetite. So your choice between investment C and B depends on your risk appetite. If you have a higher risk appetite, you would choose to invest in investment B. If you have a lower risk appetite, you would choose to invest in investment C, because they are all found along the efficient frontier. So your choice between investment C and B will depend on your investment, your risk appetite. If you have a higher risk appetite, you would choose to invest in investment B. If you have a lower risk appetite, that's when you would choose to invest in investment C. Are we on the same page? Here, maybe to be more accurate, I'll put 12.5. Why I'm putting 12.5, don't worry about it. I'm just trying to make sure that my assessment, they balance as well. Because there's another theorem which is not important for now. Are we on the same page? Are we on the same page? Any questions? Anyone lost? So that's basically how you make decisions between investments on the efficient frontier, and why would you choose to invest in investments which are found along the efficient frontier. Any questions? Now, when it comes to individual investments, your efficient frontier, this is basically how you plot the efficient frontier when you look at individual investments. Now you need to compare it as well with an efficient frontier of what? All investments in a particular portfolio as well. So if you look at figure 1.3, this is basically what I was trying to demonstrate to you when you look at comparison between the expected return and the standard deviation of these securities. And we said those investments which are found along the efficient frontier, these are the investments that you're going to choose to include in your portfolio because they allow you to maximize the return for a given level of risk, and they allow you to minimize the risk for a given level of return. So going forward, they also give us another efficient frontier as well, which is figure 1.4. And this is the efficient frontier of all investments. So this basically gives you the efficient frontier of all investments. And our aim is basically going to be, our sweet point is going to be point M. Because at this particular point M, this is basically the tangent point between the previous efficient frontier that we saw and the new efficient frontier as well. So here they say point I, if you look at, so this is point I on your efficient frontier, this is point M on your efficient frontier, and this is point J on your efficient frontier as well. And here they say point I is achieved by investing a percentage B1 is a certain percentage of available funds in portfolio M, which is the tangent portfolio, and the rest in a risk-free investment. So invest a certain percentage of your portfolio in a portfolio which is found along the tangent point from the previous portfolio, efficient frontier, and you invest the rest in a risk-free asset there. This is how you're going to be able to find yourself along this particular point. And at this particular point, your choice of investing in this particular point is mainly because you are basically what you want to make sure that you are basically having a lower risk appetite. So if you have a lower risk appetite, you are going to find yourself on point I. Then they also say point J, which is the other point there, is achieved by borrowing at particular. So it's going to be found by borrowing an amount of BJ minus 1 of available funds at the risk-free rate. So which means this is basically where you're looking at your weighting of BJ minus 1 is basically your weighting that you're going to be allocating to the risk-free asset. And then the balance of the assets in your portfolio, you invest them in portfolio M. So which means to achieve point J, you're going to say a certain weight, I'm going to borrow certain funds at the risk-free rate and take those funds and invest them in portfolio M. So this will enable you to get that particular return because your returns are going to be catapulted from point M to point J. Reason being, you are using other people's money to make money as well. If you are able to use other people's money to make money, what does that do? It gives you, you are able to exponentialize your returns, but also your risk is also exponentialized as well. So to get exponential returns at point J, it basically means that you are going to borrow a certain amount of money at the risk-free rate and then invest them at point M. That way, you're using other people's money to make more money, which basically means that you are able to now get those excess returns because you're using other people's money. Hence, you end up at what? Point J. Are we on the same page? So let's end here today. In the next class, we are going to continue from section 1.3. Section 1.3, I don't want to go through it hurriedly. Reason being, it's a highly examinable section. Section 1.3 is a highly examinable section. Usually, section 1.3, you usually find it in question number 1, of the exam. Question 1.1, usually, or 1.2, 1.3, somewhere there, you find the concept covered where you look at the capital asset pricing model. So it's a very, very important concept. So we need to leave it for the next class because it's a very important concept. Any questions? Any questions? Remember I said your exam, your assignment for assignment 1 is due on the 16th of May. So before the next class or in the next class, I will tell you exactly how we're going to be approaching assignment 1. So when we meet in the next class, which is going to be next week, Saturday, I will tell you exactly how we would approach assignment 1 as well. Are there any questions? All right. If there are no questions, enjoy the rest of your weekend. If you have any questions or if you want to be able to access the videos as well so that you catch up on, in case you missed the class or there's something you didn't understand during the class as well, I'll also make sure that I also share the access information with you as well. All right. Enjoy your weekend.
Thank you.